Good morning, everyone. It's been about a year since the last update, so there have been many interesting developments, and I have to show you my standard disclaimer slide. I don't represent the IEEE, and these are all my opinion. So why hasn't there been an update recently? I kind of was thinking about that when I was putting the slides together. And, so when this all started out, there were lots of changes, there were lots of things to report and lots of news. And I think in 2006 or 2007, I gave like 10 updates around the world on what was going on in the IEEE. But then things kind of slowed down as far as new developments, not necessarily as far as what type of work was going on. The work just kind of got boring from an operational standpoint because they started to work on draft 1.0 and got way, way deep in the electrical and specifications, and then started this thing called comment resolution, which is basically where a room about half this size criticizes every word in the draft. And they actually have a ticketing system, so every comment is put into a ticketing system, and then they go over it to make sure that it's resolved. It could be a number of things: technical changes, formatting, spelling mistakes, all those kind of things. So it's an enormous amount of work, but it's just not very exciting to report on. So recent developments, draft 2.2 was finished in August, and the IEEE calls this the crossing I's and dotting T's. It's a subtle sense of humor that they have over there, but funny nonetheless. And the big things that they're working on is called the sponsor ballot and then draft 3.0. Bottom line is things are on schedule for 2010. So you've seen this slide before, but I did it in a slightly different format this time, and there are some things that have changed since last year. Again, as the IEEE starts to work on things, they figure out, well, this was a good idea, but it's not going to work practically or things like that. One change is that for those of you that are interested in a copper interface, it used to be 10 meters over copper cable. Now the distance is 7 meters just based on the technology limitations and things that were available today. The other thing that was added is for 100 meter on multi-mode, they've also added a 125 meter on OM4 fiber. So they figured out that they can go a little bit farther on OM4, which is a little better fiber, gives you a little better distance. And the other thing that I've added is now that we're getting close to, we have pre-standard product out, there are a lot of things that we can tell you about the media and how it's actually going to look operationally. So I have a line on each of the distances and speeds that tells you what kind of media it's going to be and what kind of media module it's going to be. So you'll see a lot of talk about CFP. CFP is kind of the one module that everyone is working on and standardizing towards, and I have a couple of slides on all the different type of media coming up. So for those of you that are wondering about these very interesting names like 40G base KR4, I have a table in the reference section that tells you how to decode that. So usually I skip over this slide or I put it in the back, but I wanted to focus on it this time and specifically really talk about what it means to you. So the important things as far as the IEEE is concerned are the drafts. So you see draft 1.0, 2.0, and 3.0, and these are milestones that the IEEE has to meet because something happens that corresponds to that. So for example, for draft 1.0, you see at the top is task force review. 3.0 is the ballot, which is the important one. That's the one that they're working towards right now. So the important thing to point out is that when you talk about how to get product onto the market, it's a spectrum and a very careful balance. So I drew that as kind of a spectrum line at the bottom. It's very difficult to figure out how to do market timing based on where the standards are going and what stage the standards are on right now. So for example, if you're a silicon vendor, if you implement way too early and put your silicon out there already, and then the draft changes, you're going to have to respin your silicon. And that could be a 6-month to a year process. The optics vendors have a challenge too because they're trying to build form factors, and then the switch router vendors are trying to take all these things and put it into a line card. So kind of as you look at the development of the standard, if you look at 2008 and what was going on there, 2008 was when there was lots of news to report. They were changing the objectives, and it was just way too early to implement because no one really knew what the final objectives were going to be. So those were then adopted. Draft 1.0 comes out, has baseline proposals on feasibility, not necessarily technically complete. So at this point, people were starting to think about, what can we do? How are we going to do this? Kind of scoping out implementation ideas. Draft 2.0 was really the big milestone because if you look at, let's see, that's July, that's the last technical change. So that was Draft 2.2 that was finished in August. So now there are no more technical changes. So we've already seen some MSAs being formed. MSAs are just a bunch of vendors getting together to build a product. So we have MSAs for all the new media that we need. And then we've also seen a number of first-generation pre-standard components and interfaces hit the market. And we've also seen technology demonstrations. So, again, as you get closer to Draft 3.0, things are becoming final. People can start to do more things. Draft 3.0, like I said, is really the big next goal because that's when it goes to the ballot to be approved for the final standards track, not necessarily the final standard, but it's a complicated process. So anyway, it's a big deal for the next vote. And that's when you're going to see, I think, towards the end of the year and then spring, after Draft 3.0, I think we'll see a lot more announcements about interfaces. And that's when people are really starting to ramp up for volume production and things hitting the market. And then in 2010, when the standard is available, you might think that things are done. Well, actually, that's when the real fun starts because that's when people start to work on the next generation of technology. So you have the initial technology and costs and constraints that you're working with, and as technology changes, those become cheaper. So there is always going to be something new that's on the roadmap. If you look at 10 gig, for example, when 10 gig first came out, it was a big 300-pin laser that was on there, and now we have SFP Plus, which is tiny. So think about how those technology changes are going to affect 40 and 100 gig. Okay, I think I said most of these things already. So again, the big important thing about Draft 2.0 is it's technically complete. The last technical change was in 2009, July. And we've seen a lot of first generation and pre-standard components on the market, so this is really good. We've seen a lot of media modules. The cabling systems have actually been readily available already, and I have a couple slides on the cabling. Test gear and network gear, we've had technology demonstrations. I know Ixia had pre-standard 40 gig and 100 gig interfaces at Interrupt that they were demonstrating. A bunch of the media vendors just had a big demo at this conference I think it was in Vienna last September, so they demonstrated the 40 and 100 gig CFP modules. Then the Ethernet Alliance has been holding seminars and writing white papers and having education efforts for the past several years all along, so they're trying to get the message out there about Ethernet. Let's talk a little bit about the new media modules, and I tried to, now that we finally know what this is going to look like, I can put in some pictures and you can get an idea of operational issues that are going to come out of this. QSFP has been around for a while. It's not a new thing. It's already used in InfiniBand, and then they're going to extend the use to 40 gig short-range interfaces. And the thing to remember about this is that it's really targeted for high-density and data center applications. And the way it looks, I just did a Google image search for QSFP, and this is what came up. But it's a copper or a fiber cable assembly, and has 4 channels. It's really low power consumption, so vendors love that because you can make your equipment really dense. CXP module. This is a relatively new module. It's not brand new. It's already used. It's proposed to be used for InfiniBand and 100 gig interfaces. It has 12 channels, so obviously 100 gig would only use 10 of the 12 channels. And again, this is a short reach interface, low power consumption. It's small, it's compact, it's about the size of an XFP, and this would be a cable assembly as well. I have a picture of the Finisar fiber assembly, but obviously 100 gig copper would be some sort of twin-ax cable that is connected to a CXP. And then CFP, so this is the new module that's been developed specifically for mostly 100 gig, but there are also some 40 gig CFP modules. This is it's a big Hankins laser, so it's a lot bigger. It consumes a lot more power, but you can do a lot more with it. So from a design standpoint, There's lots of electrical connectors on the back, so you have lots of channels into the media, and you can kind of do some cool things. I don't know if you were at the Beer and Gear last night, but Alcatel actually had one, so you have to pick it up and hold it. So it's about twice as big as a Zen Pack. For those of you that don't remember Zen Pack, it's about this big. So CFP is about that big. And here's some examples of all the things that people are doing with CFP. So again, 100 gig and 40 gig, there's a variety of combinations. This one, the Reflex Photonics one, is kind of cool. You can see they actually put two 40 gig ports in one media module. So that's an interesting thing that you can do with it. And you'll notice that on the Reflex Photonics modules, there's a kind of weird looking connector that you might not have seen before. So that's an MPO connector, and we'll talk about that in a little bit. Oh, and here's MPO. MPO is a wonderfully strange acronym. It means multi-fiber push-on. So I don't know who came up with that, but it's basically a high-density cabling system. I've never seen it deployed today, but I did a lot of Googling, and there's a variety of cable systems for MPO to MPO, and then there's these cassettes that you put into patch panels that have a breakout on the back, or you can just get a breakout cable into SC or LC or whatever. But so it's basically a high-density cabling system with parallel fibers. So for 40 gig, it's a 12-fiber MPO, and then for 100 gig, it's a 24-fiber MPO. Again, not all of them are used, but that's just the packaging that the cabling comes in. And I was thinking about this. So this is going to make cross-connect a challenge. So people that provide infrastructure and data centers are going to have to think about how to do this if operators actually need MPO or kind of cross-connects. And then switches and routers again. So Alcatel had a cool card on display last night. You got to pick it up and hold it. A lot of vendors have announced 100 gigs per slot. So the usual suspects, and then capabilities for 40 gig and 100 gig. Alcatel and Juniper had the first 100 gig interface announcements earlier this year. So kind of cool, and again, you can see that they're using the CFP media. And then, like I said, after Draft 3.0 in November, I think we're going to see a slew of announcements for more pre-standard stuff, sort of the fall or winter, and then spring of 2010. So again, what to expect. So this is the first generation of technology. It's going to be somewhat expensive, and it's going to be low density. So in the IEEE, the cost choices were made so that hopefully a 100 gig interface will be cheaper than 10 times 10 gig interfaces. That may not be initially true in the first interfaces that we see. I don't know the pricing for the Alcatel or Juniper interface, but I know it's not a cheap interface. So it's basically you're going to be initially for people that really need it and can afford it. And there's a lot of trade-offs. There's operational issues. Is it more cost-effective for me to run a 10 by 10 lag or a 100 gig interface operationally? How do I manage that? Maybe people just look at hardware costs. Hopefully people look at the big picture. So in the near term, lag may be more effective for you. But again, keep in mind, and I made this point a lot in my early presentations, but the higher speed interfaces are going to make 10 gig denser and cheaper. So if I just think about my previous employer, Force 10, in 2002, we had a 2-port 10 gig card. 2004, we had a 4-port 10 gig card, and then 2009, a 10-port 10 gig card. So, the interfaces are getting cheaper, and like the street price now, I think on a 10 gig port has got to be less than $1,000. So whereas in 2002, when it first came out, it was probably several tens of thousands of dollars. So we'll see the same trend in 40 and 100 gig Ethernet. And obviously, the density has to improve. So there's going to be a next generation of switching and routing gear. While I think a 1-port 100 gig interface is pretty awesome, I don't think anyone considers that reasonable density, especially when you consider that a lot of the operators that I've talked to are actually going to deploy a 100 gig lag the first time around. So they're not going to deploy a 100 gig interface single on their backbone. They're going to lag at least 2 together for redundancy purposes. So when you have a 1-port 100 gig interface, you don't get a lot of density. I mean, you quickly run out of the 14 or 16 slots capacity. So reasonable density, I consider 4 ports to be a reasonable density. So that's going to take at least 400 to 500 gigs per slot. And that's going to be a next generation of technology. And like I said, the costs are going to decrease as new technology becomes feasible and obviously volume increases. So future meetings, The IEEE has several regular meetings, interims and plenaries. So draft 3.0 the sponsor ballot is the big ticket item for next time, because that gets the IEEE state machine into the next state for the standards approval. And you can get all of the information. If you'd like to attend an IEEE meeting, they're a lot like the NANI meetings where people are sitting around kind of reading their mail, but I just think there are more beards at the IEEE and less people at the bar. So it's kind of the same thing. You can read all of the public documents on this webpage if you're interested, all the presentations and all the eye charts if you're a double E. If you're interested in that kind of stuff, go look at that. One of the comments I got back from the PC on my draft is they wanted to see the URL for the actual draft specification. Well, unfortunately, you have to go to the meeting to get the password for the draft, so I can't put that up here. But definitely read up on it if you're interested. And then since we have pre-standard stuff on the market now, I think it's time that this gets on your radar. So if I were an operator, I think this is what I would do. I would look at network growth and needs in the next couple of years, probably like through 2012 maybe, and ask for roadmaps from people. This new technology is going to affect a bunch of your systems. So your optical gear, your switching and routing, servers. If you run a lot of servers, they were really pushing for 40 gig interfaces as a server interconnect option. So you may see server vendors starting to offer blade chassis or something like that with the 40 gig interface that you're going to need to hook into your network somewhere. And then also talk to your transport providers and your IP transit providers and your internet exchanges and figure out what they're going to do in the future and what makes sense for you. And then others, I don't know. If you have billing and provisioning systems, they're going to need to have new interfaces and new products and things like that added. And then really, figure out what's missing and ask your vendors for it. Will it work with your optical infrastructure, your cabling? Are you going to have to upgrade your cabling? Remember the MPO connector for 40 gig short reach. There is no 40 gig reach right now. Do you need 40 gig? That's something that you need to think about. And if you need it, start asking for it. Do you need Ethernet OAM? And do you need jumbo frames? So these are all kind of things that you can ask your vendors for. And then what's next? So if you look at the technology that we're going to need to really be to really drive the cost down, there's going to be demand for other interfaces, and that's okay. In some of my early talks, you can go look at the archives. We have pictures of the block diagram and stuff like that. So the point is that the standard defines a flexible architecture. So there's allows, as technology changes, it allows new stuff to be plugged in really easy without going back through that multi-year IEEE process. So this is really good. So we expect a lot more MSAs to happen as technology develops and becomes more cost effective. So, yeah, we'd love to do a serial 100 gig right now, but no one could afford it, so it doesn't make sense. So I think we're going to see serial specifications for 40 and 100 gig. I think we'll see a duplex multi-mode fiber specification for short reach interfaces, and then also I think we'll see higher speed signaling for backplane applications. And then this is kind of an interesting one. I don't know if anyone's following this, but the IEEE, so the energy efficient Ethernet, is working on some algorithms that would run in the switching and routing equipment to actually reduce the speed if the interface isn't busy, and then to ramp up the speed if the interface becomes busier. So their theory is that reduces the power consumption around the world by some extraordinary amount. So I think this may be a possibility of something that could be incorporated into a 40 and 100 gig. So I don't know how useful it is, but something that they're looking at. And then if you had a crystal ball, I think everyone would agree that no one's asking for slower interfaces or no one's seeing less traffic. I mean, we don't have people asking us for 10 meg interfaces and things like that. So this is good because the need for terabit Ethernet has already come up multiple times, both in the industry and in the operator community. So there's already some discussions about what's next and how is Ethernet going to evolve. And the IEEE I mean, I don't have an interest in the IEEE other than that I attended a lot of meetings, but the IEEE, their theory and philosophy is that they really want to promote Ethernet. So they're very pro-Ethernet, and they want to see Ethernet change. Unfortunately, it just changes a lot slower maybe than we need it. I think people could argue that 100 gig is a little bit late right now, but this is just the way things go. So I have a lot of interesting references. I mean, I consider them interesting behind this slide. So the whole IEEE standards process, you can see exactly what goals and what milestones have to be hit in the state machine to get the next state and things like that. But so that's the end of the presentation. And anyone have any questions, comments, or interesting thoughts? Right. Well, thanks.